Now next one is the sinusoidal signal. Sinusoidal signal I already discussed with you. Then you have another signal is called the exponential signal, real or complex, whatever. Real exponential signal. This is my real exponential signal. So how do you represent this? So this is x of t. X of t is equal to a e raised to the power alpha t. This is the mathematical representation of the continuous time real exponential signal, where both a and alpha are the real values. These and two are the real values. Now, how I can represent this signal? This signal will be represented for the condition alpha equal to 0, alpha greater than 0, and alpha less than 0. So what will be the graphical representation for this real exponential signal? So you have to just, I will draw the graphical representation for all these three cases. So I am first taking the case x of t equal to a e raised to the power alpha t for alpha is equal to 0. For alpha equal to 0, this graphical representation of this signal will be this. This is my amplitude A, and this is my t, this is my 0. And when I talk about the alpha greater than 0, in this case, the graphical representation of x of t, this is your t, the graphical representation will be something like this. This point is A. When I am talking about the alpha less than 0, the representation of the signal, this is x of t, this is t, this will be represented as this, and this point is A. So these are three different ways for doing the representation of the signal. So these are some of the very elementary kind of a function